So today we are going to be talking about lesson 10.2, which is solving square root equations. The square root of x plus 5 equals 13. We're going to do five different examples today. And basically the goal is to solve for x. So if we zoom in on this one, then what we want to do is subtract 5 from both sides. Oops. And then, let's do this in. So minus 5, and then we get square root of x equals 8. Now, the opposite of square rooting is to square, but I need to make sure I'm squaring the entire side. So then square root cancel, and we're left with x. 8 squared is 64. That's my solution, and I do want to check. Okay, if I put 64 in, then I get square root of 64 is 8. 8 plus 5 is 13. Yes, that does work. Here we have 3 minus the square root of x equals 0. We could move the 3, but then I'm left with this negative. So I'm just going to add square root of x to both sides. And then I get 3 equals square root of x. And then to undo that square root, we square. And we get 9 is x. And again, we want to check. So if we plug in 9, 3 minus square root of 9 is 3. 3 minus 3 is 0. Yes, that works. This one is a little bit more complicated. So we're still trying to isolate x. So we need to get rid of this 3 right here and this 4. And then eventually that 2 as well. And the square root as well. So let's start by subtracting 3 to both sides. And so we get 4 square root of x plus 2 equals 16. The 4 is on the most outside, so I'm going to divide by 4 because it's multiplying. And we get square root of x plus 2 is now 4. Square both sides, and we get that x plus 2 is 16. And subtract 2, and we get that x is 14. So then let's go back and check to see if x actually is 14. So 14 plus 2 is 16. Okay, so 4 times square root of 16 is 4. So that's 4 times 4 plus 3. 16 plus 3 is 19. Yeah, that works. So our next problem, we have square roots on both sides, and so we can just square both sides, and those will disappear. So we have 2x minus 1 equals x plus 4. So the part on the inside didn't change. We just got rid of the radical. So then we can subtract x to get x on one side, and we get that x minus 1 is 4. Add 1, x is 5. Plug that back in. 2 times 5 is 10 minus 1, and we're square rooting, so that's the square root of 9, which is 3. So let's see if that happens over here. 5 plus 4 is 9. Square root of 9. Hey, that's also 3. Yep, it works. Okay, so for this problem, we have the square root of, x equals the square root of x plus 6. So we want to square both sides because we have a radical over here and it's already isolated. So we have x squared equals x plus 6. Now I have a quadratic with the quadratic, linear, and constant terms. So I'm going to put them all on the same side, and I'm going to put them on the side where the x squared is positive so that it's a little bit easier to factor. We have a leading coefficient of 1, so 1 times negative 6 is negative 6. Two numbers that add to this negative 1 would be negative 3 and 2. So this is going to be x minus 3, x plus 2. Okay, so then we can solve for each of them, set them both equal to 0, and we get x is 3 and x is negative 2. But we still need to check and see which ones work. So we have 3 equals the square root. If I plug in 3, then I get square root of 9. Yeah, that works. Okay, so that's an answer. And then if we plug in negative 2, we get negative 2 equals the square root of negative 2 plus 6 is 4. Negative 2. Square root of 4 is 2. If there's no variable, then we don't necessarily say that it could be plus or minus 2. So this is not good, and so that means that this is what's called an extraneous solution. So we ignore it and say that that's our only solution. Okay, that's it for today. Let me know if you have any questions after you have done your homework.